Mark Occhionero, Senior Scientist and VP of Technical Sales here at CPS. Today I want to specifically talk about our AlSiC material and why it's used in high-power electronics such as IGBT power modules, which is an insulated gate bipolar transistor. IGBT power modules are used in a number of power applications, including traction, you may know it as trains and subways, power generation, wind and solar, hydroelectric, power grids, and even EV and HEV, or electric vehicle and hybrid electric vehicles. What's common in all these applications is that they have high power cycling, which equates to thermal cycling. And without good thermal dissipation and a controlled thermal expansion coefficient, the materials that are assembled and the devices that are assembled in the IGBT run the risk of delamination. The weak link in this assembly is the solder joint joining the substrate to the base plate. There have been many studies on this, the most famous one in September of 2001 that compares copper and AlSiC assemblies. After about 4,000 thermal cycles, the copper is nearly delaminated, which reduces the thermal dissipation area. For the AlSiC base plate, the thermal interface is uncompromised after 30,000 thermal cycles. This is a significant improvement in reliability. And there is another difference. AlSiC is much lighter weight, with higher strength and higher stiffness, making it applicable for power modules used in avionics and space. Being lightweight with a high strength and a high stiffness makes AlSiC less vulnerable to mechanical shock and vibration, which can compromise reliability. There are other reliability attributes that I will discuss in later videos. Thank you.